Work energy power, assignment question 1. Now, if you look at the question, there are actually two parts to it. In the first part, you can say that the block travels with initial velocity of 5 meters per second, and it slides up incline of 30 degrees, right? Up 1.5 meter, stops, and then slides back down again, right? Now we consider the first part whereby it stops. It starts from here, it stops here, right? It starts at A, it stops at B, right? So all the kinetic energy at A will be converted to gravitational potential energy at B plus the frictional losses. Okay, so how does it look like, the equation? I'll say right by the principle of conservation of energy. Okay, half mu square, that's the initial Ke, right, equal to half, no, it's not, it's equal to mgh, the gravitational potential energy, right, plus the frictional losses, which is 1.5 multiplied by the frictional force, right? Force multiplied by the distance covered is the work done, right? So that's the energy loss. Okay, so that's equal to half mu square plus mgh. Now the height, right, is actually, this height is 1.5 sine theta, sine 30 degrees, right? Okay, now, and this is equal to half u square minus g times 1.5 times 0.5 by sine 30 degrees m, right? Okay, if you look, m is equal to 44 divided by 9.81, right? 25 u square minus 9.81 multiplied by 1.5 multiplied by 0.5 f. Now if you calculate it, if you give it a calculation, right, let me see whether I'm right. Okay, half u square minus, yep, it's good. F will be calculated to be 15.4 Newton. Okay, now we consider the second case whereby you see it slides up, right, stops and slide back down again. Okay, now when that happened, okay, here's your initial Ke minus the final Ke, the speed whereby it goes down, right? Now when it slides up, stop, come down, right, at that point it has a certain speed, right? So the initial kinetic energy minus or rather, okay, let us look at it that way. The initial kinetic energy, right, is equal to the final kinetic energy, right? Now there's no change in gravitational potential energy when it comes back down, right? But it has frictional losses that covers 3 meters. You see, 1.5 meters up, 1.5 meters down. Both directions has got frictional losses, right? So the initial kinetic energy will be equal to the final kinetic energy, right, plus 3 meters multiplied by f. Okay, now that means half mv square is equal to half mu square minus 3f. Okay, we already know what is f, right, and we know what's m. Okay, consider m is 44 divided by 9.81, right? v square equal to half 44 divided by 9.81, right? U square 25 minus 3 multiplied by 15.4. Okay, you can actually calculate V. V will be calculated to be 2.10 meter per second. That's it.